Urinary system. Main questions of the lecture. A urinary system consists of kidneys. They provide the urine production. Ureters, urinary bladder and ureter provide urine storage and passing. Kidney, ureters, bladder and ureter somewhere here. Kidney situated in ureteroperitoneal region. Ureters. Kidney bean shape, concave, hilus. Here ureter, leaf kidney, pelvis, corpuscles, cortex at the periphery and medulla, lobules or pyramids between 8 and 18 in the kidney. This is a hilus, a renal artery, start from abdomen aorta, enter the kidney, as well as nerves and a renal vein and ureter, leaf kidney. This is a corrosion preparation when arteries fill in with red plastic and urine passing organs fill in with yellow plastic. Blood vessels of kidney, a renal artery branching for interlobal arteries, then arcuate at the level between cortex and medulla, then interlobular arteries, afferent arterioles, and capillaries network, glomerulus. Then afferent arteriole, it can be smaller as compared to afferent. Then secondary capillary network, which surrounding renal tubules. Then veins remove the blood, interlobular, arcuate, interlobal and renal vein. At the section of kidney which was injected into arteries by red ink, you can see interlobular artery, afferent arterioles and glomeruli. Kidney is parenchymal organ. It's covered by connective tissue capsule and connective tissue septa enter inside, and parenchyma represented by epithelial tissue. There is convex lateral margin and concave medial side. These are renal sinus, pelvis and corpuscles, large and small. Parenchyma consists of lobules, pyramids. Their apical portions produce apex of pyramid. Kidney consists of an outer part, cortex, and inner part, medulla. there is waving borderline between cortex and medulla, because a medullary rays enter cortex and renal columns extend to the medulla. Nephron, the structural and functional unit of kidney. Every kidney contains more than 1 million of nephrons. Nephron consists of capsule, consists of two layers, visceral and parietal, and renal tubule, about 5 centimeters long. So the total length of renal tubules of every kidney about 100 kilometers. Capsule and capillary glomerulus compose renal corpuscle or renal body. This picture demonstrates renal corpuscle in 3D. Capsule, outer and inner layer. Inner layer cover the capillaries of glomerulus. Glomerulus consist of 30-50 capillary loops. Between inner and outer layer of capsule there is the urinary space, cleft-like cavity. Renal corpuscle here, glomerulus, pink blood in blood capillaries, and capsule consists of two layers, outer, parietal, lining by simple squamous epithelium, and inner, visceral, consists of special flat cells, podocytes, which closely cover the blood capillaries of glomerulus. Blood capillaries lining by fenestrated endothelium, and this black line is basal membrane located between endothelial cells and podocytes. It's common basal membrane. And this is a barrier, filtration barrier between blood and lumen of capsule, urinary space. So glomerulus under scan electron microscopy, afferent and efferent arteriole and capillary loops, and this is the surface of endothelial cells under scan electron microscopy, and you can see the numerous pores, fenesters of endothelial cells. At this section you see endothelial cells, nucleus and thin layer of cytoplasm. These pores cover or not covered by a diaphragm. These are endothelium of blood capillaries, fenestrated endothelium, basal membrane, and surrounding podocytes. Every podocytes have the body and processes. This is a scan electron microphotogram of capillaries of glomerulus covered by podocytes. Under high magnification you can see the body, large processes, cytotrabecals, and from there the small processes cytopedicles, and there are intercellular clefts between. This is a filtration barrier, the barrier between blood or blood capillary and urinary space. It's in blood, erythrocyte and platelet, blood plasma. This is a fenestrated endothelium. You can see numerous fenesters, holes. Podocytes processes with intercellular clefts between, and thick basal membrane. These are three components of filtration barrier. Through this barrier, the blood plasma filtrated into urinary space up to 180 liters per day. This ultrafiltrate or primary urine is a blood plasma without large proteins like fibrinogen and globulins. This is a renal corpuscle and convoluted tubules around. In this corpuscle you see the capsule lumen, urinary space, and glomerulus. There's no glomerulus, and entrance to the renal tubule became visible. Renal tubules, proximal convoluted tubule, loop of Genle consists of descent limb, thick and thin, ascending limb, thin and thick, then distal convoluted tubule, which enter collecting ducts, and then papillary ducts. And here the secondary or final appeared. The amount of final urine, the diuresis, is 1.5 liter per day. So 99% of primary urine should be returned into the blood. They appeared from blood and return into the blood, into the secondary capillary network. This process, called reabsorption, it starts in proximal convoluted tubule, called the main part of nephron, because in this part of renal tubule the proteins, glucose and lipids, as well as sodium and chloride ions, calcium ions and water, are absorbed from the lumen, from the primary urine to the blood. And the reason why these epithelial, cuboidal or columnar epithelial cells have special ultrastructures on apical portion, microvilli, which compose brush border, for organic components reabsorption, in basal part, basal striation with mitochondria, for reabsorption of salts and water. Microvilli in the apical part, brush border, and folds of basal cytolemma and mitochondria in these folds form the basal striation for absorption of ions and water. Mitochondria provide the energy for ion pumps. Distal convoluted tubule, some smaller, and has empty lumen because no microvilli, no brush border, because no reabsorption of organic components. But basal parts has a lot of mitochondria. Here, reabsorption of sodium ions stimulated by aldosterone of suprarenal gland take place. So, renal cortex consists of renal corpuscles, renal bodies, and convoluted tubules, proximal and distal. The straight tubules, collecting duct and papillary duct compose medulla of kidney. This demonstrational preparation shows the accumulation of blue dye, specifically in proximal convoluted tubules of nephron. They are located around the renal bodies, and they reabsorbed blue dye from primary urine and accumulate and stain themselves. You see the distal convoluted tubules nearby without blue dye. It demonstrates they are not able to reabsorb this dye. So this slide demonstrates three processes of urine production in kidney. Filtration in renal corpuscle, reabsorption, then primary urine reabsorbed in renal tubules. The proximal convoluted tubule reabsorbs glucose, proteins, lipids, sodium ions, and some water. And here in distal convoluted tubules reabsorb natrium and chloride. As a result, the osmolarity of blood here increased, and water enters the blood by simple diffusion. Reabsorption of water takes place in thin segments of loop of Henle, as well as in collecting tubules stimulated by antidiuretic hormone of neurohypophysis. The third component of urine production is secretion. Take place in opposite direction from blood into urine. By this creatinine and drugs are absorbed in proximal convoluted tubule. In Henle loop, the urea are absorbed. And here, in collecting tubules, hydrogen and chloride ions secrete, so the composition of urine changed. Endocrine system of kidney, its main part, juxtaglomerular apparatus, consists of dense sport. Its accumulation of epithelial cells of distal convoluted tubules which go between afferent and efferent arteriole. These chemosensory cells can control the concentration of sodium ions in the urine, primary urine. If sodium ions increase in concentration, these cells exciting and convey excitation to juxtaglomerular cells, which produce and release renin into the blood. And renin is enzyme. This provide conversion of angiotensinogen to angiotensin 1, then converted by special enzyme to angiotensin 2, which stimulates the secretion of aldosterone by zona glomerulosa of suprarenal glands, and it stimulates the reabsorption of sodium ions in distal convoluted tubule. The amount of sodium in urine increase, and it attracts water by simple diffusion. And increase blood pressure finally. This apparatus can increase blood pressure and blood pressure in the capillary of glomerulus, which is necessary for filtration. Filtration, the blood pressure in blood capillaries of glomerulus should be more than 50 millimeters of hydrogen. The juxtavascular cells and mesangial cells can also produce renin and release it into the blood, help to juxtaglomerular apparatus. Urine passing organs consist of calicles, small and large, and pelvis. They are intrarenal. Urinary passing organs and ureters, urinary bladder and ureter, belong to extrarenal urinary passing organs. All these organs lining with transitional epithelium. You see the renal pyramids, the apex, where the papillary ducts release the final urine into the calicle. These blue calicles, they're lining by transitional epithelium. This slide demonstrates also the reason of waving borderline between cortex and medulla, because renal corpuscles, renal bodies in the cortex located at different level. There are corpuscles, nephrons, which located just under the capsule. So in this case, straight tubules and deeper in the cortex, medullary rays. And if renal corpuscles located near medulla, there are convoluted tubules enter the medulla as renal columns. The scan electron microphotographs nicely demonstrate the apex of a renal pyramid, lobule, papilla, papillary ducts, visible on the section. It's called ara cribrosa, and a renal small calicle, lining by transitional epithelium. So here initially accumulated the final urine. Small calicles fuse to the large calicles, and large calicles fuse to the pelvis, and then continue to ureter. All urinary passing organs are tubular, consist of three membranes: mucous, muscular, and adventitial or serous. So the ureter is typical tubular organ, consists of three membrane, mucous membrane, lining with transitional epithelium, lamina propria, loose connective tissue under epithelium. Then lamina muscularis consists of inner longitudinal and outer circular layer of loose connective tissue, enteroid adventitial membrane, which consists of dense connective tissue. A urinary bladder wall has the same plan of structure, mucous membrane, very thick muscle membrane consists of 3 layers, mostly serous membrane outside. The mucous membrane lining by transitional epithelium. Mucous membrane compose folds. They're visible under scan electron microscope. And transitional epithelium here in free state of the bladder. The surface epithelial cells are round in shape, and here several layers of intermediate cells. So the functions, the urinary system and kidney in particular, is the removal of harmful waste products of metabolism from blood, urea and creatinine and some other, derived from protein metabolism. Excretion of drugs and other breakdown products, excretion of water and salts, so kidney regulates the water salts and acid bases balances. Endocrine function of kidney, production of renin, prostaglandins and kinins, which regulate the blood pressure. Secretion of erythropoietin, which regulate erythropoiesis in red bone marrow.